All right, my friends, let's do some more macro markets and quant data. Working on the National Income Project. If you've been following along, at this stage, we're looking at top line. You have all of your data curated. You have it loaded in. You have your project open. Mine's called National Income Class Copy. Go ahead and check out yours. If you're looking at this and you're not part of the class, let me know. Maybe I could get you some of the materials, but you can still follow along with the code that I am showing you through the video, as well as the concept discussion. I'm going to clean up a little bit here. Let's close all others. Neat little feature of our studio. So top line is revenue equals prices times quantity. We already discussed quantity. We want to focus on price. Our macro model starts at PCE because that's what the Fed watches. That's what's inside of the Taylor rule, and wants to go all the way to the price of output. That sales price. But there's a lot of differences between the two. Remember, take a look at the top-down profit framework. So we're going to use PPI, that final demand PPI, as a way to bridge the gap between the two. So we're going to connect PCE to the PPI, then connect PPI all the way over to that price of output. That will allow us to have a shock to our macro model and see how it could permeate, not just to the prices, but potentially to the top line. So first thing we want to do is go ahead and dip into our macro data. Now let's just make sure if you have the same object as me, go ahead and run everything up until then. It cleans it, loads everything that you need, checks for errors and such. All right, so we're good to go. Now, this is going to pull into macro.annual.log. Let's just make sure everybody's up to speed. Go ahead, Excel looking thing, like a little table. 1934 TB3MS is the variable value and delta. What in the world is TB3MS? Uh, if you are a Fred nerd like me, of course, that's the 3-month treasury yield. But go to the metadata files. And those metadata files that I have in here contain all those definitions. And if you worked with us before, would you know that we did the data prep file, which has that in there. So it's got date, variable, value, and delta. Look at the different variables. There's many such these variables. If you want to see exactly what's in there, you could just scoot through them, or you could do macro, annual, and variables tab, and it gives you a listing of all of them. Pretty neat. So now I know how to pull them, not just what's in there, but how they're capitalized and what are the mnemonics. I want to pull PPIFD, the PPI final demand. The Dippler pipe operator is going to give us the way to go into that data frame. I want to go down that long data frame and just pull out the columns where the variable is for the PPI. I want to select only the date and the delta. Those are the only two I need. I don't even need to keep the variable because it's PPI. And I'm going to drop any of the NAs. If I'm pulling delta, remember, if you think about the way a delta is calculated, you're going to miss that first one. So I'm going to drop those. And again, as it says in the instructions there, the way in which Fred pulls data is often 5 is 5%, but our calculations were 0.05 is 5%. So you do a little mutate to be able to scale that. Boom. So now we got a temp object. I want to merge that temp object with the inner join. And let's make that a little more human friendly. So you could read through them. And remember, whenever you're doing the inner join, you have to figure out what you're joining on. What's that binding column? In our case, it's going to be date. Make sure that it says date, capital D-A-T-E, not just on what you're writing, but in both of the objects. We're going to go into the rev.p.delta created previously and meld it, join it, merge it with this temp.ppi. And we're going to rename. If you remember the rename, it's new equals old. New name equals old name. So I'm going to call it PPI. What am I calling PPI? That which was written as delta.ppi. Let's take a peek. Each row is another date. Each column is another object. I'm pausing because you should be looking at this thinking like, that's not a hell of a lot of data. And you're right, it's not a hell of a lot of data. So whenever we're going to go through and do some analysis on this, you have to throw a big grain of salt at it. We could do the quarterly data in the National Income Project. I do collect some of that, but for our purposes, we're just playing with annual. So that's a big caveat. All right, so now what I want to do is take that and convert it to long. The way that you convert to long is with pivot longer. We're going to take the two columns, PPI and rev.p, and we're going to stack them. We're going to keep the dates. We're going to stack those two. So if we stack those two, PPI and rev.p, we're going to create a new column called variable, which will contain either PPI or rev.p. And all the numbers we'll just call in a column called delta, variable delta. We saw those before. I'm using purposely the same naming convention. Helps with the code. So PPI.p.long, PPI.p.long. All right. So now what I want to do is, oh, actually, let's show that to you, PPI.p.long. I just wanted to say it again. Now you can see what it looks like. Look at the row 1 and row 2. They're both 2011, which might seem that you made a mistake, but in the long format that the computer likes to read from, it's stacking the variables. It's not the typical human readable wide form. All right, I want to plot them out. And the way we've done this before is when I want to overlay two lines, I've had two different geom objects, two geom lines. With long form, it's a little bit easier. What do you want to put on the X, the date? What do you want to put on the Y, the delta? It sounds like I'm doing the cheerleading. What do you want to put as the group, the variable? And what do you want as the color variable? It's the grouping and the coloring that is telling you how you want to distinguish between these objects. I'm going to put a geom line, I'm going to add some points, and the rest are just labels, stuff like that. Fancy schmancy, do the ggplot. That's a work of art right there. So what does this mean? This means that the rate of growth in the PPI, final demand, matches very closely the output price of goods in the economy and services, not just goods. And that's exactly what it's supposed to be, right? The PPI final demand is capturing a wide range of products. Unlike what most people often think, I read in the press, is that the PPI is not like wholesale prices. The PPI is about those selling prices. It's related to the CPI, and I think that's what causes the confusion. The gap between the PPI and the CPI is in part just, is it surveyed through the people who buy it or surveyed through the people who sell it? And the gap between those two would be like taxes and things like that. But the PPI also has other advantages because it's much wider. It's not just the consumer products. It's also government investments and export stuff. So it really captures the broad swath of economic activity, which is what that top line revenue pricing structure is supposed to be. So this is great. I can map these two things together very closely. Now, I want to explain the revenue pricing with the PPI, which means I need to create a model, and I want my Y explained by my X. The LM function, the linear model, that linear model is going to be the regression framework where it's a y tilde x, y tilde x. What I'm trying to explain with what I'm using to explain. And then I'm going to reference the PPI, that price structure that we built just a moment ago. And once you run that and your summary on that, you get the typical regression framework that we all know and love if you're in Excel or SAS or Stata or whatever else, or Python. The beta is right there, quote unquote beta. The coefficient, the slope. For every 1 unit increase in the PPI delta, gross output price growth rises by 0.89. So remember, our deltas are written as 5 is 0.05, right? 5% is 0.05. So if PPI grows 1% faster, that's going up by 0.01. Then output's going to grow 0.89% faster. That's what this means. It's going to go by 0.0089 faster. So let's compute the correlation between these two. That's what the core function, 0.9999. That was a great show. You can see how tight those two things are. 2 degrees of freedom. I mean, I should have my stats license revoked for running regression with 12 degrees of freedom. I mean, right there. So you shouldn't really trust any of these correlations and linear regressions. I mean, we can see just visually there is a relationship between them, but it's hard to say something statistically rigorous with just 12 observations. We can do better a little bit later. So what I want to do now is do some predictions. I want to predict 2025 price growth using the annualized PPI growth rate observed in the first half as a proxy for all of 2025. So again, I'm trying to predict the revenue dot pricing, PPPI now, using an input. And what's the input? The first half over second half percent delta annualized for that PPI. We have that. It turns out if you go to Fred and you grab that ticker, PPI FID, it's growing at about 3.3% annualized for this first half. So remember, the annualization is what if it grows at that rate for a whole year? Our data is annual, so that makes sense. What I want to do is create a new input, a new object called new underscore PCE. So what if the relationship, making a lot of mistakes here, PPI. So what if the new PPI was 3.3? We're going to do this new PPI. And we'll input that into the predict command. Now, the predict command not only needs that new PPI, which is what you're feeding into the input, but also the name of the regression model, which we just formed. So basically what it's going to do is go up here and say, all right, take 0.007475 plus 0.89333034 times 0.33. It's going to do that math for you. The predict command does that math for you. I'll format it, make it look nice and neat with a percent and multiply by 100 so it's human readable. And when you do that, you get 3.02%. So we're estimating growth to be 3.02% for 2025 if the PPI keeps on going at the rate it's been going for the first half. That's what we think. Total revenue, PQ. So we're focusing on the P, how fast those prices of goods sold and services sold will be for all of 2025. And remember, those pricing structures come from actually an index value. And remember, when you're thinking about translating growth rates into levels, you need to take that base of the level and multiply by the gross growth rate. Don't get confused with the term gross here, right? If you have 100 and you want to grow it by 2%, what do? You do 100 times 1.02, 1 plus 2%. That's a gross growth rate. So that's what we'll do here. We're going to grab that tail, which is the end. So that's the last single one data point. And then 1 plus, that's that gross growth rate, times that last price, format it nice and pretty, and you get, it should be 129.12. So we're predicting that price level to be 129.12. What's going to be more informative is we're going to have that growth rate of about 3%. So we're thinking top line price growth should be about 3% in 2025. We talked in previous videos about the quantity top line growth rate, which I think was much lower at like 0.8% or something like that. All right, so let's pause for a second. All right, so that was only one piece of the puzzle. Rewind back, remember. Hey, this is a video, so you can't rewind back. Remember, we want to go from our macro model to our business's output pricing. Macro model has the PCE connecting to the PPI, going from the PPI to our pricing. So we just did that last piece. How does the PPI feed into the pricing of our output of goods and services? Now we want to see how the PCE is going to impact the PPI. Once we have both of those pieces, we can hit the chain and see what happens. So let's connect the PCE to the PPI. That would be through like a Phillips curve or something like this. Theoretically, we've talked about that in our theory. So we're going to dip back into our macro data long. We want to grab a couple of these. You see the variables. We want to grab two of those types of variables. You notice there's not a lot. We don't see any PPIs way back in the 70s. We have to go more recent stuff to see the PPIs and the PCEs, and we don't even have her for 2025 yet. So we're going to have, again, a limited data set. I want to grab within there pipe operator, snag. Filter the variables. We've done that before. Either the PPI or the PCE. PCEPI is the Fred ticker. So use the in the pipe operator on that column vector of those two. Make sure you got the quotes. And then what I want to do is I want to select the date, the variable, the delta. Before I didn't select the variable because it was only one variable. I didn't need to carry that around senselessly. Sounds awful, right? Drop any NAs. We know there's going to be NAs. I just showed you, right? We don't have some of the recent dates, and then scale them to make sure that they match our other work. Then what I want to do is plot them out. Now, I don't need to train them, or pardon me, translate them and transform them to be long because macro annual long is already long. So all you need to do is grab the date, the delta, and then group them by that variable. Remember, group by tells you how it's going to distinguish. We're going to plot them out with geom lines, add on some points, add on some fancy dancy. Oh, I didn't run this yet. Boom, boom. And there you go. Now, we have two series, one with a much longer history than the other. The PCE, which is the price indicator the Fed uses, has been around since the 60s. The PPI has not. For the periods over which they overlap, they look pretty good. It tends to be pretty tight. So remember, PCE feeds in the PPI, PPI is feeding into the goods and services stuff that we're selling, that pricing structure. So can the PCE explain the PPI, the blue and the reddish, pinkish, orangish line? I don't know what color that is. They look pretty close to one another, not perfect. I don't expect them to be perfect. So let's actually create a balanced panel with a wide structure. So we're going to dip into that long. We're going to pivot wider. We're going to grab the variable names from the columns, and then we're going to fill those columns with the delta values, values from the delta. Remember, we have that the PCE, PPI, PCE long. Let's take a look at that so you get a good feel for that. We're going to dip into all of these. Look at that. They're all the same one, all the same one. It's only until here that they change. So we're going to dip into those, and then we're going to rename them so it's wide. And when you do it wide, it looks like this, what you would typically think about. Notice it's not balanced, right? So what we want to try to do is think about maybe scraping them away. Thankfully, the way that the LM function is going to work is we don't even need to do that. We could put over here, we could put NA dot omit, and that'll make it balanced. But let's say you forget to do that. The LM command will take care of that for you. It's going to drop 51 observations deleted due to missing this. Missing this. Don't think I ever read that word like that. LM, linear model, regression, Y tilde X. What you're trying to explain with what you're using to explain. The data is the object that we just made, the PPI PCE wide, and there is your quote unquote beta. 1 percentage point, 0.01. Increase in the PCE growth rate, increase the PPI by 0.015 percentage points. All right, so 0.015 percentage points, but this says 1.5. That's because of the scaling. Don't forget the way that it's set up, right? Look at the units. The units are that 0.02 is 2 percentage points. So divide these by 100 to be able to interpret it to our framework. Now what we can do is put these things together. We can do a little scenario analysis for this. So suppose the Phillips curve was calibrated like such, where we got pi, which is inflation today, time t, is going to be by expected inflation minus 0.025, that gap, unemployment rate gap of the current minus the NIRU, that's with the star, plus whatever shocks there could be, supply side shocks, etc. The negative side meaning that they move in opposite directions, as a Phillips curve would say. Suppose the unemployment rate rises from 4% to 4.5%. What's the impact on the price of output? All right, so there's a shock in our macro model. In this case, it's a shock to unemployment. How's the rest of our system endogenously going to change to react all the way to your corporate business pricing? So in our case here, the delta UR I make that bigger for you. The delta UR is 0.5 percentage points, going from 4% to 4.5%. Ceteris paribus, all else remaining the same. The change in inflation, that delta pi that we talked about up here in this formula right there, is going to be minus 0.025 times 0.5. Now, why didn't I touch the ET pi t plus 1, the UR star, the E? Because none of those change. Ceteris paribus. If the only thing that changes in the unemployment rate, the only thing you need to consider is the things that append it, that touch it, 0.025 and the change in the unemployment rate. So if you multiply those two together, you get minus 0.0125, which means the change in PCE is minus 0.0125. Now be careful. The way that we set it up in our top-down framework and in our code, just for expediency, is that when we say PCE, it's actually the growth rate in the PCE. It's not that level. So 1.25 percentage points slower. PCE growth rate should be growing 1.25 percentage points slower than it was when the unemployment rate goes up. So if unemployment rate goes up, inflation should slow. We're not saying there should be outright deflation. If unemployment rate goes up, inflation should slow by, in this case, 1.25 percentage points. So we want to take that shock from unemployment to the PCE and see how that impacts the PPI. Well, we had a regression before that the PPI coefficient was 1.54. Remember, we had it right there. PCE on the PPI was 1.54. So that should mean that the PPI should grow 1.925 percentage points slower. Okay, so unemployment rate hits, PCE starts to slow. That's going to relate to the PPI starting to slow. Okay, but how do I get to the businesses? Well, don't forget, we also regressed the PPI on the price of output. Well, that was the beta on that was 0.89. Go back, rewind the video real fast, and what you see is that's 0.89. So 0.89 times the minus 1.0925 is about 0.017. So that's a lot. Basically, here's the story. Unemployment rate was 4%, went up to 4.5%. That slowed PCE inflation, which slowed PPI inflation, which slowed the price and lowered the growth rate over which businesses can pass along price increases to customers. So if you take a look at where prices were growing in 2024, they were growing at 2.03%. Now, if they're slowing by 1.7, that growth rate is slowed down by 1.7 percentage points. That means that it should barely be growing, right? So in 2024, we saw that the price of output was growing at around 2%. But if there's this unemployment rate shock, 2025 businesses increase in their price points would only be 0.3%. 2.03 growth rate minus the 1.7 growth rate, they slowed by 1.7 percentage points. You got to work through that problem a couple of times for it to make sense because you have not only the coding, but also the story with that macro model going from the unemployment shock, the PCE, PPI, all the way down to the price of goods and services sold. Last thing is just to check about the prediction. We could work on the prediction from before if we look at a PPI growing at 3.3% over the first half. We put it inside of our regression model, then we can get the formatted value. You put those pieces together, and what you find is if PPI, pardon me, quantity of growth is growing by 0.84 and price growth is about 3.02, then it should be about 3.86 for all of 2025. Huh. Pardon me. It should be about 3.86 for all 2025. All right, so go back to where we started our story. We're looking at top line revenue growth in the United States for all companies, corporate, sole proprietorships, etc. total revenue, we think because of the relationship with GDP, could grow by about 0.8 percentage points in 2025 if GDP continues moving at the pace it currently has been. That's the 0.84 right there. Next up, what's going to happen to pricing? Well, if PPI continues moving at the pace it has been for the first half of 2025, that would imply that businesses could pass along about a 3% increase in their price structure. So 3 percentage points from pricing, 0.8 percentage points from revenue would be about just shy of 4% growth for 2025 for top line revenue for the US. That's in the ballpark of what it was in 2023, but slower than it was in 2024. All right, hope that helps.